SQL, or SQL, the structured query language. SQL has a long history. It goes back to a research project at IBM in the early 1970s called System R. System R is one of the most important computer science research projects in history, actually, along with a companion project at the same time at UC Berkeley called Ingress. System R and Ingress were attempting to prove that the relational model, which was at that time a theoretical idea, could actually be used to deliver a useful and high-performance database system. So those two projects were in research phase in the 1970s, and each had its own query language. System R had a language called SQL, which stands for Structured Query Language, and Ingress had a language called Quell, and those two languages competed in various ways, as did the research projects. Eventually, they were both brought to commercial products in the early 1980s, both Quell and SQL, and SQL ended up winning in the marketplace, to the point where Ingress founder Michael Stonebraker ended up calling SQL intergalactic data speak. All right. Actually, another interesting historic anecdote from that time is that IBM was not the first company to sell an SQL database. A little startup called Oracle was the first company to sell an SQL database, beating IBM to market by a short time. Oracle had been reading IBM's technical reports and went ahead and implemented a very compliant version of SQL and brought it to market before IBM released their original DB2 database. SQL's been around, as I said, for a long time. It's over 40 years old at the time of this filming. And over those years, it's been questioned repeatedly. In the 1990s, for example, there was a movement to change the relational database out for something called an object-oriented database that would take advantage of ideas that we see in object-oriented programming languages today. And there was a query language called OQL that was developed for object-oriented databases. Very nice language, but didn't really take off in the market, nor did the object-oriented databases. The next decade, in the 2000s, with the advent of the World Wide Web, the World Wide Web Consortium proposed a data representation called XML, which we still have today, and no less than 3 standard query languages for querying XML. The first and most completest of those languages, XQuery, actually shared a designer with SQL. Don Chamberlain, who is the researcher at IBM who led the SQL design, also was one of the leaders of the XQuery design. Again, XQuery, very nice language. It was implemented in a number of actually relational databases, but didn't take off in the market and is not widely used. In the last decade, there's been an interesting movement called the NoSQL movement that tried to reject SQL in favor of more programmatic languages for developers, like simply putting and getting values or keys in a database, or writing MapReduce programs popularized at Google for analyzing data. So there have been various systems to support these workloads, and yet even in this past decade, SQL has reemerged as the standard. So the sort of MapReduce influenced systems like Hadoop and Spark today see that most of their workloads are generated by SQL interfaces to those systems that were written some years after the original systems were built. So SQL, maybe it's not perfect and maybe it's not to everyone's taste, but it is sort of everywhere when you're working with data, and it's quite useful and powerful, so it's what we'll study in these lectures. It has pros and cons, like any language. One of the features of SQL that's quite interesting is that it's a declarative language, probably the most important feature of SQL. A declarative language is a language in which you say what you want, but you do not say how to compute what you want. You leave that decision of how to compute things to the database system. This is important for a couple reasons. It means it's a very high-level language, so it's fairly simple to specify rather rich queries. And in addition, you can say a query, and one day the database might compute it with one strategy. Another day it might compute it with a different strategy based on changes to the data or changes to the hardware or changes to the contents of the database. So that's an important feature of database query languages like SQL, is that they are declarative. We'll talk about that more in this course over time. SQL has been widely implemented across systems as small as things that run in your phone, like SQLite, and as big as things that run across the globe in the cloud. And it's been implemented in a variety of sizes and scales with a variety of levels of efficiency. Some of these systems are faster than others. And a variety of levels of completeness with respect to the standard for SQL. So some of the SQL implementations you'll run across will not support all the features that you'd expect in SQL. So keep that in mind. SQL is a constrained language. It's a domain-specific language for querying and manipulating data. It was not targeted to be a Turing-complete programming language, and if you're trying to write algorithms, it can be rather uncomfortable to do it in SQL. It really prefers to be used, if you will, in a way to manipulate and query data. That said, it is general purpose and it's quite feature-rich. Over 40 plus years, a lot of features have been added to the SQL standard. And it's, among other things, extensible, which means you can call out from your SQL query to a traditional programming language like Python or C or Java or what have you. And so you can mix your queries and imperative code from traditional languages, which makes it fully expressive. So you can do a lot with SQL if you want to or you need to, but it was really mostly designed for querying databases.